We've been talking about counting methods, basic counting principle, permutations, combinations, and we've also been studying probability. So in this video, we're going to put those two concepts together and try to answer some problems. Now, the first example, I'm giving you step by step how to work out the solution. But in other problems, we're just going to be asked to find the probability knowing we have to do these three steps. All right, and the same thing's going to happen in the homework. So for this one, we have 3 men and 3 women lining up at a checkout counter at a store. First question, in how many ways can they line up? So I'm just lining them up, 6 people in order. It's a permutation. There's no repeats, and I'm choosing all 6 of them. So I could do the permutation of 6 things taken 6 at a time, or I could just simply use the fundamental or basic counting principle and write that out. So 6 times 5 times 4 times 3 times 2 times 1, which we also know can be represented as 6 factorial, and that will give me 720 different lineups. So part 2 says, in how many ways can they line up if the first person is a woman? Well, now instead of having 6 here at the beginning, I have to say no, there are only 3 women, so I only have 3 choices here. And then after that, it doesn't matter. So for part B, we would have 3 times the 5 times the 4 times the 3 times the 2 times the 1. Okay? Now, that gives me 360. And the final question is then, well, what's the probability that the lineup has a woman as the first person in line? Well, probability is favorable outcomes divided by total number of outcomes. So part B tells me the number of favorable outcomes, 360. Part A was the total number. So my probability here is 360 divided by 720 reduces to a 1/2 probability. But recall, we can express probability also as a decimal, 0.5, or as a percentage, 50%. Okay, so those are pretty much the 3 steps. Figure out how many total possibilities there are, how many favorable outcomes there are, and then do that division problem to get your probability. So in other problems, that's going to be assumed that we know those steps. So let's take a look at a few of those. This one says we have 5 performers, A, B, C, D, and E. Rather than names, we'll just give them letters. They're appearing at an event. The order is determined by random drawing. Can we find the probability that D will perform first? Okay, so favorable to total. The favorable outcomes would be D performing first means there's only one choice for that first position, right? 1, and then we don't care who comes after that, so there are 4 choices, then 3, then 2 times 1. So that's the top. The bottom says, I don't care who goes first. There's 5 choices. And then the next is 4, 3, 2, 1. So when I write it out this way, I can see a lot of things cancel, and we're left with a 1/5 probability, or 20% chance. That should make sense because there are 5 performers, so 1/5 chance that D is going to be first. The next one's a little bit more complicated. It says we want to find the probability that A will perform second and E performs last. Now, if you think you've got an understanding here, go ahead and hit pause, write it down, and then check your answer. All right, let's talk about it. So for this one, we are going to have the second space, on that one. Second space, there's only one option for A. And the last space, there's only one option, that's E. That's taken 2 out of the 5 performers, leaving only 3 to decide who gets to go first, and third, and fourth. So it's 3 times 1 times 2 times 1 times 1 on the top. The bottom, same as above. So again, we're going to cancel out what we can. This time, we have a little bit more arithmetic to do, and we're going to come up with a final answer of 1/20. Okay, so a less probability that that's going to happen. All right, last one. Again, if you think you're understanding this, go ahead and hit pause and see if you can figure out the probability that B or C will perform first. All right, let's take a look. So B or C tells me I have 2 possibilities for the first position. Once I've chosen that, then whoever I didn't choose is now in the whole mix, and we don't care who goes after that. So then it's 4, 3, 2, 1. The denominator is still going to be the same, line up 5 times 4 times 3 times 2 times 1. And so we'll again reduce where we can, and this time we end up with 2/5 probability. Again, that kind of makes sense to us because we know that D performing first was 1/5 probability, 1 out of the 5. But if I say, well, it's B or C, then I have now 2 out of the 5 possibilities. So it makes sense. Let me know if you have any questions.